Just a little background. I've been in HPC for I don't know a dozen or more years. Spending time in a variety of different industries and joining AWS about 2.5 years ago. And so what I want to talk about is not going to be quite as in depth as I think we went into in some of the cache sizes and such as in the processors, but I want to talk a little bit more about the AWS side of it. So how can you use this type of technology? And so, as we kind of spoke, there's obviously a lot of customers are using HPC in a lot of different ways. Some of them are using it on-prem, obviously, and others have moved to the cloud. So for those that aren't familiar with it, we want to talk a little bit about what it means to run HPC in the cloud and perhaps a little bit about how that can change things. Then I'll spend most of the presentation kind of talking about some of the underlying HPC services and what supports you being able to run your workloads in this sort of environment. And then close out with some customers that have run today on AWS and some of the insights we have from that. So as we were just talking in the previous sessions, right? HPC is really around us all. I don't have a Pringles can here, right? But everything from the simulation of the car you've driven to how did we get the fuel out of the ground, right, efficiently so that you can use it in your vehicle, to your weather forecast. Despite us not being as good as we would love them to be, right? Without HPC, they would be so much worse. To financial modeling, as well as the things that aren't sort of the classical HPC, but use a lot of the same gear that we've talked about. For example, with machine learning and recommendations around what movies you want to watch, as well as even the ray tracing and things that we do there. So really, HPC is everywhere, and commonly we have customers that come to us and say, look, why is it that I should use the cloud, or often they already come to us and say, look, I have a pretty good idea on what they want, right? There have been various surveys that say, people lose time right when they sit in a queue, right? It's sort of a consequence of how we've built HPC over time, is they typically are a shared resource, and we try to run them at a fairly high utilization, right? It keeps costs down. And they're also fairly homogeneous, right? But some of the problems we find are that, because we might have to wait so long to get that answer, we might say, look, I really need that answer like today. I don't have time to wait till next week, so I'm not going to sit in the queue. So I'm just not going to ask that question, right? Or they may be saying, look, the technology I have today, right, I'm going to keep using it, and you have to do a lot of analysis before you go buy a system, right? Because you don't want to make a wrong decision, because you're often gonna, keep that, 3 years, or certainly you have customers that will use it, 5 years. And so, you kind of lose a lot of time potentially while you're trying to make that decision as well. And also, and I think the third one that comes up a lot that people don't often realize is sometimes we're limiting what questions we ask, and perhaps even in some cases what algorithms, if we're designing, if we have our own applications, is we're kind of limiting ourselves to what runs well on our hardware today, right? So the ability is, can we sort of free ourselves from some of those limitations? And the other one that I think most often comes up when people think of a cloud environment is, how do we match demand to capacity? Right, so if you talk to probably many of you today, right, if you run an HPC system, you're probably looking at a utilization anywhere between 50% on generally a fairly low end, to many customers I talk to today that say, look, I run at 90+% utilization. Right, it keeps my cost lower, right, because I'm using it all the time. But it also means that any sort of peaks that would normally occur in my usage, like I really wish I could have this answer tomorrow, but I'm going to wait, several days or more, because I just can't sort of burst or use more than I have deployed on my data center floor right now. It's just very hard, right? So you end up having delays while you procure new hardware, and then you probably have too much hardware potentially at some points. Right, so is there some way to optimize that? So often the metric we like to look at is really, what's your time to results? What's the business value you get out of it? And there's often a mix, right? For some, it really doesn't matter if it takes a week to get a result. We become very accustomed to it. But others, right, especially if we start thinking outside the box, right, is there some value to doing something that maybe used to take me a month and I can do it in a few days? Right, so rather than kind of squishing all of our workloads into our existing box, can we maybe think and scale differently? So if you're not familiar with Amazon, right, this may be something you haven't seen, but if you're not familiar with it, this won't be a surprise, right? A big thing with Amazon is working backwards from what our customers tell us. And this has sort of informed how we do some of our HPC and our services. So a lot of asks come up from those that administer these systems, right? Depending on your industry, you may have security requirements, certain data governance. I got to keep it for a certain amount of time. I've got to have a certain number of copies. Of course, I want it to be managed according to cost, right? I can't there's no limitless budget anywhere that I know of. And of course, how do I manage my data itself, transferring it, whether it be in an on-prem environment or elsewhere, as well as those sort of functional or business asks, which is, how can I get a faster development cycle, right? Can I do another iteration of this design, or can I have my engineers not try to multiplex multiple, jobs at the same time, right? Can I keep them fully occupied with this task, right? So I don't sort of waste their time, right? Often our people are our most expensive asset. And also, what other tools can we have, right? As well as easier access to data. And so today, through all of those things, we have folks that run all of these different types of workloads, like the ones I showed on the first slide, medicine, others, to where we just spent a lot of time talking about fluid dynamics types of use cases. Certainly have all of those running today, as well as customers doing weather forecasting, reservoir, molecular dynamics, sort of the whole range of applications. And so what I want to talk about is kind of how do we get there, right? What are these underlying services that we can use to provide a real HPC environment that we were just talking about earlier, right? We care about things like cache sizes. We care about, how well these scale, efficiencies. And so it's super important that we kind of understand the building blocks below. So the first element is going to be the compute, which many of you have probably heard about before. EC2 is our elastic compute cloud. And so EC2 is really, we like to say, the compute platform for every workload, right? But when we look at it for HPC in particular, it means that we can change the processor, right? So when we hear about, look, this works really well on an AMD processor, right? A Rome or whatever it might be, right? Let's choose that one for this workload, right? It allows us to scale tightly coupled ones, and we'll talk about the network there, as well as being able to sort of select how much network bandwidth do I truly need for this workload. Now, often in HPC, we like to, have full access to our hardware and full performance. And so if you go back a number of years at AWS, you would find that the virtual machines that you would be given didn't quite match the underlying processor, right? So if your processor was truly a 24 core, processor, you might only see, 20 of them being available to you. And the reason for that is because there are actually overheads associated with virtualization, right? Whenever you're doing IO operations in particular, it had to go through an extra layer, right, to make sure that you're truly allowed to do that. And so over time, AWS took all of those things that slowed us down, put them all essentially into hardware. And so we've called that really Nitro. And so Nitro cards here, we've moved in all of the networking. So all of that virtual networking stack that allows you to segment your network and everything, all of that is in a separate card. The way we implement virtual block devices, so how we can basically provide a virtual disk on any cluster or node you have. Instant storage, so how do we make sure you have the exact rights to the NVMe device that may be local to that hardware? How do we do that? That's all offloaded. And so Today, with all of our newest generation instances, when you launch an instance, you truly get all of the resources. So you're no longer, have to worry about potentially any noise. You don't have to worry about the fact that, well, I see a weird number of NUMA domains or anything. No, we can pass through all of the NUMA domains and you have the full system at your disposal. Right, we also have cool stuff that I won't go into around our security chip, right, which allows us to basically segment off all of that hardware. So we can even provide you bare metal access. So it looks very similar to a hardware, to our virtualized one, but we can just give you the bare metal one as well. But due to the performance differential being essentially negligible, right, most of our customers will choose to just continue running in a virtualized environment. So when it comes to all of those instance types, which are really those virtual machine types, we have a broad variety of ones. Right, so we are talking, in some cases, our application works super well if it has a very high clock speed, right? It may not work so well if we have, many, many cores. And so we have options that allow you to choose, right? Do I need kind of a Goldilocks one that works pretty well everywhere? Or, do I need a really fast, one for single threaded code? So, we have ones where all of the cores will be 4.5 gigahertz. Right, we have others that are going to be a lot more cores, right, but they'll be a little bit slower. Right, we allow you to choose whether you have a local NVMe device or not. How much memory do you need? Right, do I need 4 gigabytes per physical core, 8 gigabytes, 16? Right, we allow you to choose those. And so together, right, we have, I think the slide was built as 390 plus. I'm sure we're over 400 today, but really allows you to choose the instance type that matches what your application needs to do, rather than saying, okay, my hardware is this, how do I figure out how to change my application or my problem to best map? So we were talking a lot about AMD today, and so I wanted to include, obviously AMD is a great partner. We released the EPYC Gen 1 parts back in 2018. And then we've also released the Gen 2, which is the Rome components on AWS. And as we've announced at the Gen 3 launch of Milan later this year, we will also have Milan-based instances. So all of the performance that we kind of saw earlier in the day, those will be the things we can use on AWS as well. So we're really excited to have that with our partner AMD as well. In terms of other elements, right? We kind of think about the compute node, and then we talk about the networking separately. So talk about Elastic Fabric Adapter, or EFA, right? So a lot of people, when they think of HPC, they kind of say, well, it must be InfiniBand or like our Cray friend Slingshot or something, right? What we've done is instead of taking kind of an interconnect that's used for the on-prem world, we've taken the approach of, let's do something that's very specific and optimized for how we build our cloud networks. So what we've done is built Elastic Fabric Adapter, which has a lot of the same capabilities and interfaces you'd see in a typical HPC interconnect, but we'll do it for the cloud as well. So you may be familiar with libfabrics or the Open Fabrics community. And so what we've done is we've made Elastic Fabric Adapter usable through the libfabrics library, which allows us to be usable through OpenMPI, Intel MPI, right, as well as NVIDIA's Nickel library and such. So it gives you a lot of those same benefits of we can avoid OS bypass, right, which can slow down our transfers, increase our latency by moving to this. And additionally, we wrote our own protocol, and there's an IEEE micro paper that if anyone's interested, I could forward along, around our SRD protocol, which is scalable, reliable datagram, which is really a model that allows us to use all of the networking paths that we have within our cloud network. So if one is slow, right, or something gets dropped, right, the hardware itself is spraying across multiple paths. So we don't end up with long tail latencies that you can see even with HPC interconnects at some point, right? So in this, right, we can see sometimes what people truly say when they don't want to run on TCP/IP is that it's really slow to interact to, a link going down or losing a packet, right? It essentially resets a timer. And we can see that using SRD and EFA, there's the same link down event, right? It's basically flipping. You can see there's very little impact on the throughput we're seeing for EFA in this case, right? So what we end up seeing is in real applications, this gives us tremendous performance advantages over using, just the standard TCP/IP. So this is just, a CFD++, but we could see similar sorts of graphs, with software from ANSYS and others. But you can see without using EFA, so this was just standard TCP/IP, we have the lower purple graph. And what you really ideally want to see is that red, which is perfect scalability. And you can see in this case, it's great up to like 400 cores. And then this particular case kind of trails off and can't get any faster. And then when you further try to scale it up, right, the overhead of splitting up the computation across more and more cores and trying to communicate becomes so bad it actually starts running slower, right? Whereas if we look at using EFA, right, and we see this with other HPC interconnects as well, is that it allows you to scale much higher and further out to larger number of cores, right? Because the networking performance is so much better. So you can see, even on this case, here, 24 million cells, we're already, we still have 75% scaling efficiency. So this is, really a great showcase to say, look, EFA allows you to scale despite it, not being InfiniBand or something else. But the great part about EFA, right, is that it's not just a single instance type, right? So we have these on instances that have GPUs. We have these on instances that have high frequency clocks. We have them on instances that have lower ones with bigger, lower amounts of memory. So it's really across the board, and that's what makes it an exciting sort of technology. Is no longer is HPC just a cluster kind of off to the side, right? It can be sort of integrated across this wide variety of different hardware. So with that, I want to spend just a few minutes talking about storage. So we have a lot of different storage options, but typically when we talk about HPC, people are saying, hey, I really want this high performance parallel file system. And for many of you, you've probably heard about Lustre. Lustre is a very popular file system, especially at large scales. Many of the largest supercomputers in the world use Lustre. But what we heard from customers was, hey, I love Lustre, but it's kind of painful to administer. And so, they said, is there a way to make this easier? And so FSx for Lustre is really an Amazon managed Lustre environment. So you just say, what capabilities do you need, right? Do you want it to be running on SSDs? You want to run on hard drive, based media? How much storage do you want? And through an API call or a web console or a CLI interface, you can just say, create me a file system, right? And it can do that. It can return it back to you. And we have customers such as TRI, using it for large scale machine learning, but we have plenty of others using it for a wide variety of HPC applications. And so you can choose a number of these capabilities, how much speed you want from every terabyte you've provisioned, right? So in this particular case, I'm just showing you one where we're provisioning, 200 megabytes per terabyte. And you can see we can scale linearly out with our storage capacity. So the great part of this is I can set up a file system with whatever performance characteristics I need, right? Generally, this is far exceeding what most people would have in an on-prem environment. The other great part is it's not just sort of your standard Lustre file system that is sort of static over time. What we've built into this is the ability to stage data in and out of object store. So in our case, S3 is our object store. Object store is pretty efficient and cost-effective way to store files. Right, the problem is most HPC applications require a POSIX interface, right? We need to be able to open, read, and write throughout different parts of the file. And that doesn't work so well with an object store. But what is great is we can use the object store essentially as our repository for all the data, and we can hydrate that directly in from S3 into FSX, operate on the data, and then when we're finished, we can push it back to S3, and we can, if we want, just shut down our FSX file system. So I have the ability, right, to do whatever I want. I can use it as a normal file system, keeping it up for, days, weeks, months, or I could, for each whatever job or project, right, I could have a different file system, spin it up and then shut it down when I'm done with it, and just store it within S3 at a very, cost-effective price. So the last part I want to talk about is sort of the management and orchestration. So I hope, after listening to me, you're saying, hey, that is really cool, Matt. I like the idea of everything you said. I could customize my hardware. I love the network, right? I love this idea of storage, but I don't want to have to piece all this stuff together myself, right? And so, of course, you can put it all together yourself. It's great. But we also have customers that say, hey, help me with this. And so for that, we have a product called AWS Parallel Cluster, and it's actually fully open source. So you can go download it off GitHub and look at the source if you'd like, contribute patches back. But it really integrates all of those services I just spoke about, right? It can do FSX for Lustre. It allows you to choose different instance types. It allows you to use EFA. It also has nice DCV, which is that remote visualization part. So Tony had said in his presentation, right, you need to be able to view your data, decide what you want to do next. Right? And so nice DCV is a high performance protocol that allows you to do that. So Parallel Cluster, right, it's just a set of, essentially it's a tooling that allows you to set up that entire infrastructure. It makes it look very similar to an HPC environment that you might use today, or you might find somewhere else. So it allows you to programmatically set up all of those elements. So you can set up different queues with different processor types or instance types, right? And just set it up whenever you need the job. So this particular graphic here is just showing someone installing the Python, library that's required for Parallel Cluster. They're setting up a config file, and now it's just waiting here for that infrastructure to launch. So behind the scenes, it's creating a file system, right? It's actually launching those nodes. It's setting up the scheduler, right? So when you log in through SSH, right, you can then see a scheduler. In this case, it's showing, Torque, I believe, or SGE, but it could be Slurm, right? And in this case, it's fully set up for you. But the best part is that it's not just sort of static. Right? So if I show you this graphic, and it's a little busy, but the great part is it's building you a login node, right, where you can log in, compile your code, set up your job file, submit whatever you might like. It also runs the scheduler. But the great part is it's going to start up, and it really doesn't have any other resources. So only when you submit a job, it could go start up those resources for you. Similarly, when there's nothing running anymore, there's nothing in the queue, it can shut it down. Obviously, there's lots of customizations. Some people want to just have nodes running, and you can do that. And you can say, never allow me to go above a certain number of nodes. There's a lot of functionality, but it's setting up your file system, it's setting up your scheduler, all those things that you would normally have to do. It's automating all of those for you. So it's a pretty great tool for people that are looking for that. Now, we also have customers that say, hey, that's great, but I want to be able to do this totally programmatically, right? I want to fully embrace, containers. I want to have things triggering off, changes in my environment. So like maybe somebody uploads a file. I want it to automatically start processing that and then dump it out at the end. I don't want to have anybody messing around with SSH or anything. And for that, we have, AWS Batch, which is really a cloud native orchestrator and scheduler. So you can configure it to use events. Like I said, maybe somebody updates a database or somebody adds an object to your object store, right? It could trigger running something within AWS Batch. Similar to my other example with Parallel Cluster, it can then automatically start resources. It can run them. When it's finished, shut it down, and then it can trigger other events within AWS as well. many customers running these sorts of things. I have an example there with Mobileye uses this for autonomous vehicle simulations, right? They're running on Spot. So Spot is really preemptible sort of capacity. It's excess capacity within AWS. So we provide it at a large discount if you're willing to, have that potentially interrupted with a 2-minute warning. So Batch is another great opportunity with that. So we have, like we said, we started with, we really have workloads across a wide variety of industries, right? Everywhere from life sciences, financial services, weather forecasting to autonomous vehicles. And so, even if you don't see your particular vertical here, we would love to talk to you about it because undoubtedly, we have some customers in that area, right? We also worked with F1, right? So, they didn't have access for wind tunnels for, a year to 2 years. And so, they had to use CFD, right? And so they moved from sort of their on-prem environment where it was taking 60 hours to they could do it in 10 hours, right? It also allowed them to scale up and down depending on, what problem they wanted to solve, right? And I won't read the quote there at the bottom, but it's one of those where it truly changed sort of the way they could look at how they could use, CFD. So kind of what I've shown you here is only a very small slice of what's possible within AWS for HPC. We also have a wide variety of partners, right? So obviously AMD is a great one of ours. There are many others that are not that won't fit on this particular slide here, but we have those that provide technology and work with to make sure it runs well on AWS. We also have other partners, right, who can help you implement this sort of technology specific to your company as well. So all of those, and we also have products that build on top that can provide you different interfaces. So it's a wide variety out there. So in closing, I'm hoping all of you are thinking about, what potential business problems you could solve with this type of environment. And maybe think, what are the ones I currently have today that I'm solving, right? But maybe if I change some assumptions, like what if I had 3 times as much compute, or 10 times as much compute at certain times? What could I do? So with that, if you already are working with AWS, you can find whoever it is in your company and tell them, hey, I want to talk about HPC to folks in AWS. They can come find us. Otherwise, if you don't have that, you have my email address there. But we also have a web link, which is to our HPC services page. There's also a link there that says, hey, I'd love to know more. So if you fill that out and you click the little checkbox that says, hey, I'm willing to be contacted, we will then reach out to you.